So let's start. Let's start with acyl chlorides. Uh, s- Actually, we had to do comparison of bases. I'm going to do that very quickly. Okay, let's do that in nitrogen compounds. We need to finish acyl chlorides. So very quickly, we're going to talk about formation of acyl chlorides. We did the comparison of hydrolysis early on. Okay, that was done. And we did the comparison of all chlorine-related compounds. Now, acyl chlorides were these things. We did the mechanism of the substitution reaction of acyl chlorides, which was an addition elimination reaction. So their formation. How are acyl chlorides formed? The way they are formed is you take a carboxylic acid and you react it with, you substitute the OH in the carboxylic acid with a Cl, and that is done by SOCl2 plus heat or with PCl5 plus heat. So if you do these reactions, the OH is going to get substituted by Cl. So that is formation of acyl chlorides. The next thing we want to talk about acyl chlorides is we're going to talk about the formation of esters and amides. So starting with formation of esters. Esters are formed, normal esters are formed, like there are different ways of forming esters. Uh, One way is that you react a carboxylic acid with an alcohol. And that results in the formation of an ester molecule and a water molecule. So that is one way. So what happened in that reaction was that you had a carboxylic acid molecule and you had an alcohol molecule. So there was OH group on the other side. The H and the OH, and there's an OH over here. So just one second. So there's an OH over here. Both OH groups are going to react, and the carboxylic acid would lose its OH, and the alcohol group would lose its H, and they would end up forming water molecules. And the rest of the molecule, it's going to combine and it's going to add up. So the OH is gone. I mean, these things in the middle are gone. The H and OH are gone, and the double bond O would react to form a bond with oxygen, and an ester molecule is going to be formed. And the conditions for this reaction was the conditions that you use for this reaction are concentrated H2SO4 and reflux. Plus reflux. So that was how esters were formed in this reaction. This is an O levels reaction, and we need to learn how to name esters as well. So, for example, I have ethanoic acid reacting with propanol. So ethanoic acid plus propanol. How do you form the ester? It's going to be two carbon atoms. This is going to be a carboxylic acid group. There would be three hydrogens over here. The other one would be a propanol molecule. It has OH. Make sure that the functional groups are pointing to each other. So one of the molecule has to be drawn the other way around. Get rid of the OH and the H. They would end up forming water molecules. और यहाँ पे there would be CH3, C double bond O, and there's going to be O, and then there's going to be CH2, and another CH2 and another CH3. So both chains are going to be linking up by this ester functional group. The ester functional group is C double bond O and O in the middle of the chain. So this is what's happening, and a water molecule is going to be produced next to it. And how do you name esters? The way esters are named is esters are named in two parts. One part is going to be around the ester link. You're going to divide the molecule into two parts. This is eth because it has two carbon atoms, and this side over here is three carbon atoms, so that is prop. So on both sides, count the number of carbon atoms and give the name of the initial prefix accordingly. On one side, there are two carbon atoms. On the other side, there are three carbon atoms. The name is going to end for the double bond O side, it's going to end with O8. And for the single O side, it would end with while. So this one would be propyl ethanoate. The name of the molecule would be propyl ethanoate. Just remember the OH side is the double bond O side and the while side is the single O side. So that is how you learned how to name esters. Uh, let's do one more example. Let's say it's a methanoic acid and plus propan 1,2-diol. How would you form this ester? Okay, let me put. So how would you form this ester? Methanoic acid plus propan 1,2-diol. Methanoic acid is this thing. It's C double bond O and OH, only one carbon atom, so there's only going to be one H. So that is methanoic acid with one carbon atom, and you have propan 1,2-diol. That means there's going to be an OH on the first carbon atom and an OH on the second carbon atom. The rest would be hydrogens, and three hydrogens are over here. So this is propan 1,2-diol. How would they react? Uh, Two methanoic acid molecules would be needed because there are two OH groups in propan 1,2-diol. So there's going to be another methanoic acid molecule. So it's CH3, C double bond O, and OH, not CH3 because it's only one carbon atom. So there's going to be HC, double bond O and OH. And the same thing happens that the OH of carboxylic acid gets removed and the H from the alcohol gets removed, the OH from the carboxylic acid gets removed, and the H from the alcohol gets removed. And you can join them up at specifically at that very positions. Two water molecules are going to be produced in this reaction. It's going to be C double bond O. So it's going to be C double bond O, and there's going to be another O. And next to it, it would be CH2. And after that, there's going to be, Sarah, is this clear? There's going to be C.
Yes, sir.
Okay, then there's going to be CH3. Okay. And on top, there's going to be O, which would be connected directly to C double bond O. And there's going to be an H over here. So there would be two ester links in this molecule. One of them is going to be this one. And the other one is going to be this one. Okay. Ariba, is this clear? Aburera, clear?
Yes, sir.
So there are going to be two ester groups in this molecule. Uh, this is the normal ester formation that you've already done in O levels. Why are esters formed in the first place? The reason esters are formed in the first place is that the carbon over here, if we focus on this one, the carbon over here has a partial positive charge. Why does it have a partial positive charge? That uh, it's bonded to a very highly electronegative element, which is oxygen. So the electrons are closer to oxygen over here. And the oxygen over here in OH, it has lone pairs. So what really happens is when this reaction happens, what actually takes place is that the lone pairs on oxygen are very, very strongly attracted to the carbon that is having a partial positive charge. So the H and OH over here in the middle, they get knocked out. Uh, but the attraction is not very strong, which is why you need concentrated sulfuric acid and you need a reflux as well. So the alcohol OH has lone pairs, and those lone pairs they get attracted to the carbon which is positive, which is why these two attract, and the H and OH they get repelled and they end up forming water molecules. Okay, Rima, is this clear? Sarah, is this clear?
Yes.
Yes, sir.
So now the
Yes, sir.
second.
Sir, could you
Yes, sir.
show the propane onto diol structure again?
This one.
Yes, sir.
This is propane 1,2-diol. I mean, there's three carbon atoms. One OH would be on the first carbon atom, and OH would be on the second carbon atom. And it was reacting with methanoic acid. So, if it's reacting with methanoic acid, so you would need two methanoic acid molecules, or one would react with one of the OH, the other one would react with the other OH. Sahi hai? Acha, so moving on, the second method of forming esters. The second way esters are formed is you use acylchlorides. Using acyl. Now the thing with acylchlorides is that it's pretty much the same reaction. You have, I mean, there's nothing different. So you have an acyl chloride, plus you have an alcohol. They react together and they form an ester and instead of a water molecule, they form an HCl molecule. So that's pretty much the only difference. Otherwise, the reaction is very similar. Take an acyl chloride, for example, CH3, C double bond O, and Cl, and react it with an alcohol. Let's say there is CH3 and there's CH2 and OH. So here's this reaction that's going on. Exactly same thing would happen. That the Cl and the H are going to get knocked out. They would form a water molecule, not a water molecule, an HCl molecule. And the CH3C double bond O and the CH3CH2O. The H and Cl are knocked out from the middle and they're going to end up combining with each other. Okay, so it's exactly the same reaction. You get an ester molecule, which in this case is going to be eth, and this side is also eth. So it's going to be eth. The single O side is Yl, it's ethyl, and this is eth and O8. So the name of the molecule would be ethyl ethanoate. So exactly the same. Ariba, is this clear? Sarah, clear? Aburera, is this clear?
Yes.
Yes, sir.
Achha, but the good thing about this is the reaction is considerably faster compared to carboxylic acid. So the reaction is considerably faster compared to the carboxylic acid alcohol reaction. So a lot faster. So what's the reason? Why is it so fast? The reason why it's so fast is that the reason comes down to this carbon again. This carbon over here, the one that you see in the acyl group, that has a very strong positive charge. Why does it have a strong positive charge? Because now it's bonded to two electronegative elements. There's an oxygen as well as a Cl. So now the charge on the carbon atom is a lot more positive, and these lone pairs on oxygen are going to get very strongly attracted. So the reaction is going to happen at a much faster rate. Okay? In the previous case, the carboxylic acid case, the carbon was only bonded to one electronegative element. On the other side, you had OH. OH group is not an electron withdrawing group. It's actually an electron donating group because the oxygen gets electrons from H. So it doesn't need electrons from carbon. So it's not going to, I mean, this oxygen is not going to have an electron withdrawing effect because it's already getting electrons from hydrogen. So this carbon was not very strongly positive. So the attraction was not very strong. But in this case, the carbon on the acyl group and the lone pair on oxygen are going to be very strongly attracted. So I'm going to write that down. Why is it a faster reaction? As there's a stronger partial positive charge density on COCl, carbon, on carbon in COCl, which attracts lone pairs and it attracts lone pairs on O in the alcohol group. ठीक है Ali, is this clear? Sarah, Ariba, is this clear?
Yes, sir.
Yes, sir.
अच्छा, और ये हमने we did acyl chlorides when we were doing comparison of hydrolysis earlier on, ठीक है, over here. In this case, when we were doing the comparison of three different chlorine-related compounds, we had talked about acylchlorides, and over there, we saw the same exact thing happening that because of the positive carbon atom over here, this carbon atom had a very strong positive charge, acylchlorides, so the hydrolysis was much more vigorous. It would attract water molecules. Halogenoalkanes, the positive charge was not very strong because it was only attracted to one Cl, and in benzene, there was no positive charge because there was an electron cloud. And Cl, although it has an electron withdrawing effect, but I mean, there were too many electrons over here, including Cl's lone pairs. We did the mechanism of hydrolysis of acylchlorides that we discussed that because the carbon in acyl chloride has a very strong positive charge, it's going to attract the water molecule even in the cold. And even in the cold, the reaction would be very vigorous. The water is going to come in, and the Cl atoms are going to get knocked out. Eventually, you're going to get a carboxylic acid molecule. So we have discussed this about acyl chlorides earlier on as well. And the same pretty much happens over here, that you can form esters from acyl chlorides. You don't need specific conditions. The reaction could even happen in the cold. उसके अंदर previous esters के अंदर carboxylic acid के अंदर you need concentrated sulfuric acid, and you also need you need reflux as well. So moving on, hydrolysis of esters. Okay, let's talk about hydrolysis later on. We're going to talk about amides. So acyl chlorides are used to make amides. Now they used to make they used to make amides in the same way as esters are used to as they make esters. When you have an acyl chloride, which is C double bond O and Cl, And again, there's a very strong positive charge on this carbon atom. So there's a very strong positive charge on the carbon atom. On the other side, if you have an amine, you have an NH2 group with its lone pairs. The lone pairs on N are going to be very strongly attracted to the positive carbon atom. And the H and the Cl would get knocked out from the middle. So this is what's going to happen. That you will have RC double bond O. On the other side, you're going to have R and NH. Now the middle part would get knocked out, and the lone pairs on N are going to connect with the carbon over here. So this N over here is going to get connected with this carbon over here, and this is your amide link. So that's how amides are formed. So acyl chlorides are always used to make amides. C double bond O Cl reacting with NH2. Carboxylic acids cannot be used to make amides, and the reason being, or they're not very suitable for making amides. Like you can have the same reaction. For example, you have a carboxylic acid. In O levels, you did study actually that amides are formed from carboxylic acid. So you have an R. So you have an R NH2 group. Carboxylic acids also have a positive carbon atom, and the lone pairs are going to get attracted, and the H and the OH from the middle are going to get knocked out. So that would result in the formation of the amide link. You will have C double bond O that will directly connect to the NH, and there's going to be R, and H2O molecule would be produced. In the previous case, you're going to have HCl being produced because the H and the Cl are going to get knocked out. Okay? Ariba, Sara, is this clear?
Yes,
Sir.
अच्छा ये with carboxylic acid ये मैं problem बता रहा था कि with carboxylic acid you have a certain problem कि with difficult to make amides with carboxylic acids. So it's going to be very difficult to make amides with carboxylic acids. And the reason why it's going to be difficult to make amides using carboxylic acids is that carboxylic acids are acidic. They like to lose H plus one ions, whereas amines are kind of basic. So instead of this condensation reaction that's happening, you might get an acid-base reaction. What you might get is that the carboxylic acid ends up losing an H plus one, and the amine group, because it has lone pairs, it is going to end up gaining an H plus one. So acid-base reactions are possible. And they're more likely actually. So what's going to happen is you're not going to make. I'm going to. I mean, you should know the reason why this reaction is probably not going to happen. It's very difficult to make amides with carboxylic acid, so you never use carboxylic acids. You always use amides. Okay? And the same reason that the positive carbon over here is going to attract the lone pairs on the end very, very strongly. So the reaction happens at a significant rate, and it's more likely to happen. So just remember that esters can be formed using acylchlorides, and they can also be formed using the old conventional method, which is using carboxylic acids. With acylchlorides, the reaction is much faster. And what's the reason why it's faster? Because the positive charge is stronger, and you can also make amides. But you can't use carboxylic acids to make amides, which you've studied in O levels. ठीक है, is this clear? Reba, clear? Sarah, is this clear?
Yes, sir.
That's the next thing. Okay, we're pretty much done with acylchlorides. Let me just open. Okay, the next thing that we're going to study is the comparison of bases. Okay, why are certain substances basic and why are other substances not very basic? So comparison of bases. And when we talk about bases, we're talking about nitrogen compounds. So we'll be talking about nitrogen compounds. What are bases? Bases are anything that accept H plus one ions. Why do nitrogen compounds they accept H plus one ions? Because any nitrogen compound, whatever it is, whatever it's bonded to, N has this lone pair. And if there's an H plus one that's roaming around, then that H plus one is going to get strongly attracted to that lone pair. So the end result would be that the N in the nitrogen compound would accept the H plus one, would attract the H plus one and would natively bond with it. So they're accepting H plus one ions. So whenever there is N, you call it a base because the lone pairs on N can accept H plus one ions, and there are many different types of nitrogens. The key idea is that there would be different groups attached next to the N. There could be multiple groups attached. Now these groups, if they have an electron donating effect, what would happen? The lone pairs would have more or higher electron densities. So if R, or the group that is attached to the N, has an electron donating effect, so which groups actually have electron donating effect? The number one is alkyl chains. Any carbon chain that has an electron donating effect, then what would happen is that the lone pair, there's going to be higher charge density on the lone pair on N. On lone pair on nitrogen. And if there's a higher charge density on the lone pair on nitrogen, more attraction for H plus one. There's going to be more attraction for H plus one. And if there is more attraction for H plus one, it's going to be a stronger base. ठीक है? Reba, Sarah, is this clear? Ali, is this clear?
Yes, sir.
Yes, sir.
Yes, sir.
Achha, so there's going to be a stronger base, and vice versa. The other option is that if the R group has an electron withdrawing effect, so it pulls electron density away from the nitrogen. Now, if that happens, then it's going to be a weaker base. So if R group or the group that is attached, whatever is attached, has electron withdrawing effect, so if it has electron withdrawing effect, and what groups have electron withdrawing effect? Many groups. It could be a benzene that could be attached, or any other highly electronegative group like fluorine, etc. Anything that has a tendency to attract electrons. or it could be C double bond O as well, because the carbon on C double bond O is positive, so it attracts electrons. So if it has an electron withdrawing effect, there's going to be lower charge density. So there's going to be lower charge density on lone pair on N, and because of that, there's going to be less attraction for H plus 1. And it's going to be a weaker base. So that's the basic. That's the main idea of what is. I mean, it's the same as. It's exactly the opposite of what made a strong acid and what made a weak acid. It's exactly the same idea. So अब यहाँ पे you're going to study 4 molecules which have N in them. There's going to be an amide. So that's the first one. You have amide. Then you have, compare it with ammonia. Not ammonia, actually, ammonia shouldn't be here. Then you have a phenylamine. Then you have a phenylamine, which is benzene with NH2. So lone pairs here as well, and lone pairs over here as well. And the third one, then in the middle, there's going to be NH3, just for reference. And the last one would be an alkylamine, like an amine with carbon chains. So this one is clearly, I'm going to first write what the names are. This one is an amide, and it's not basic at all. Then you have a phenylamine. A phenylamine is slightly basic. And lastly, you have an alkylamine. And it's relatively strongly basic. So when you move to the right, the basicity increases. You're going to study 4 nitrogen-related compounds. And if you move to the right, the basicity of the molecules is going to increase. And the reason for that is fairly obvious, because why is the first one? Remember, amides are not basic. So each time you're going to be asked for an explanation. So why are they not basic? The reason this is not basic is that the C double bond O over here withdraws the lone pair electrons. So the lone pair electrons, and we're going to write the explanation, the lone pair on N overlaps and mixes with the pi electron cloud as it mixes with the pi electron cloud in C double bond O. So the lone pair on N over here, it gets completely withdrawn towards this oxygen, towards this highly electronegative oxygen. Okay? Ariba, is this clear? Ali, Sarah, Abu Rera, is this clear?
Yes, sir.
Yes, sir.
Yes, sir.
Achha, so if it gets completely withdrawn, it's no longer going to attract H plus 1. So agar yahan pe na there's an H plus 1 that's roaming around, then that H plus 1 would not, because there is no lone pair. The lone pair is gone. Okay? It's gone and it has mixed with the double bond. So और यहाँ पे लिख भी देते हैं कि as C double bond O has an electron withdrawing effect. अच्छा, next one is कि why are phenylamines so basic? इसके अंदर भी थोड़ा सा वही होता है कि benzene has a slight withdrawing effect. So which means that the lone pairs don't get completely pulled towards benzene. ठीक है, but they do very, very slightly get withdrawn towards benzene. So benzene has a slight electron withdrawing effect. और इसमें क्या होता है कि lone pairs overlap with benzene's pi electron cloud. So they overlap with benzene's pi electron cloud, which is why decreases charge density. So it decreases charge density on the lone pair, and there's going to be less attraction for H+1. और फिर वो आखिरी है, the last one. The last one actually has an electron donating effect. So that's the last one. If you have a carbon chain, तो उसके अंदर आप लिख लो कि alkyl chains have electron donating effect. They have electron donating effect, which increases charge density. And the more the alkyl chains are, if N is surrounded by alkyl chains, it's going to be a more stronger base. So electron donating effect, which increases charge density on lone pair on N. Okay, so stronger attraction for H+1. So is this clear to everyone? Sara, Reba, is this clear? Abu Rera?
Yes, sir.
Yes, sir.
Yes, sir.
So remember this, there would be 4 nitrogen compounds and you should know which one is more basic, which one is less basic. वो idea दे दिया कि why does basicity change? तो concept वही है, exactly same as acids, ठीक है? So we're going to continue with this tomorrow then, ठीक है? चले, okay then. कोई question नहीं है, पूछ लो वो. So we'll continue with tomorrow then, ठीक है?
Okay, sir. Allah
और
Hafiz.
पास पे करेंगे probably कल, ठीक है? Okay. Allah Hafiz.